Hello, physics students. It's request time. I had a request to go over a couple of the homework problems from the past. This is a centripetal motion problem from, I think, a November assignment. And this was question number 7. And if we just read it briefly, a roller coaster has a mass of 580.9 kilograms, and at point B, that's on top of this hill, is traveling at 4 meters per second. The radius of the dip is 6.5 meters. What is the force acting on the track at this point? All right, so this is a centripetal motion problem, which means we have to apply Newton's second law and determine the centripetal acceleration. And so what we're looking at is this circular area. And so when you're looking at these problems, so we're looking here at point B, and over in a minute we'll make a force diagram here, but you should always note where the center of the circle is, because your centripetal acceleration will be pointing to the center. So it is below point B, so the acceleration will be negative because it's in the down direction. So let's take a look. Let's start by doing a force diagram. So here is our roller coaster at position B. There are two forces, right, acting on B. We have the weight of the roller coaster, mg, pointing down. And we have the normal force from the track pointing up, because remember, the normal force is always perpendicular to the surface. So we also make a note that the centripetal acceleration is also pointing down. So the centripetal acceleration and the weight will be both negative. They're in the same direction. So according to Newton's second law, I know if I add up the forces, they have to be equal to mass times acceleration. This is the second law. But because we're dealing with this rotational motion, this is going to be a centripetal acceleration. So I can make note that this is going to be centripetal acceleration. If you look at the AP equation sheet, you'll see that the equation for the centripetal acceleration is the velocity squared divided by the radius of the motion. They give us both, if we take a look over here, they give us both the velocity and the radius. So we have both r and v, and we also have the mass. So I have the normal force pointing up, the weight pointing down, so that means that I will have that Fn minus mg must be equal to minus mv squared over r. And again, it's important to note that the centripetal acceleration is pointing below the roller coaster, so it has to be in the negative direction. And now I can solve for the normal force. The normal force is going to be equal to mg minus mv squared over r. I can clean this up a little bit by factoring out the m. That means the normal force will be equal to the mass times gravity minus v squared over r. And now it's simply a matter of putting in your values to find the force on the track. So the normal force equals mg minus v squared over r. I know what G, I know V, I know R, I know M. Make a note that on the website, the problems typically use 9.81 meters per second squared for gravity. And my velocity is already in meters per second, and my mass is already in kilograms, so you're good to go. So I hope this helps, and I'll see you in the next video.